Hello engineers, welcome to the new video of the course, and in this particular video we are going to understand that how exactly certain parameters which are mentioned over here, how these particular parameters they influence the overall resistance, right? So this is one of the most important topic, because whenever you try to learn any topic related to current, electricity, or maybe in general with semiconductors as well, so you always try to play with this particular terms, that is area, length. So how exactly this certain parameters they influence the resistance or conductivity, etc., etc. So this topic it becomes very important, not only from the current electricity point of view, but also from the semiconductors point of view. So this is very important topic. Okay, so let's say if I have certain resistor, let's say it is made up of certain material X. Okay, there is certain resistor R. Okay, it is made up of certain material X, right? Okay, so what will happen if I increase the area or decrease the area of this particular material? Okay, what will happen if I increase the length or if I decrease the length of this particular material? How exactly the overall resistance, how exactly all of these changes affects the overall resistance? Okay, so this is what we need to find out, this is what we need to see. Okay, I hope you understood what exactly we are going to do in this particular session. So as of now, what we'll do, we'll just focus upon one parameter, let's say area. Okay, so as you can clearly look over here, one sec, let me erase this. Yeah, the resistance of a material depends on the certain parameters which are as follows: area, length, and resistivity. Okay, as of now you don't focus upon this particular term resistivity, we'll see that as we move further and further. Okay, what we'll do is that we'll just focus upon area. Okay, so if this is the resistor, okay, so this will be the length and this will be the area. Okay, this will be the area. Okay, getting my point? Let's proceed further and let's see how exactly the area influences the overall resistance. Whether, like, if I, let's say, decrease the area of a resistance, how exactly it affects the resistance. Okay, or if I increase the area, how exactly it affects the resistance. This is what we need to see, or this is what we need to check. So let's proceed further, and let's say there is this particular conductor whose area is A1. Okay, and then I have this another conductor whose area is A2. Okay, just by looking at this particular two diagrams, you can clearly guess that my A2, okay, A2 area 2, that means area of conductor 2 is greater than area of conductor 1. This is what we can see. Okay, this is what we can see just by looking at the diagram. Let me just highlight this particular point. Okay, and let's say for time instance, there is some amount of current flowing from this particular conductor. It is flowing in this particular direction, right? It is flowing in this particular direction, as you can clearly look over here. And as I clearly mentioned, if the current flows in this particular direction, so the electron will always flow in its opposite direction. So in this direction the electron will flow. Okay, so this is the direction in which electron will flow. Okay, I hope this particular part is crystal clear, this particular point is crystal clear. Okay, now let's assume that there are few electrons present over here at this particular end. Okay, there are few electrons that are present at this particular end. Let's say there are 10 electrons. Okay, there are 10 electrons. Okay, what will happen is that this particular electrons, obviously the current is flowing in this particular direction, so the electrons should flow in this particular direction, right? The electrons should flow in this particular direction, right? Okay, I hope this particular part is crystal clear. Now you see what exactly this is. So this is the nucleus of certain atom. Let's say there are two nucleus. Okay, in general there will be n number of nucleus, but for understanding purpose I had just taken two nucleus. Okay, because we need to understand that how exactly things will work internally. So there are these two nucleus of certain atom which is present over here. Okay, so let me just draw those particular nucleus over here. Let me just take this particular nucleus somewhere over here, so that I will be able to understand, I will be able to explain this particular concept in detailed way. Okay, so let's assume that these are the two nucleus, and let's say there is this particular electron which is coming closer to this particular. Okay, it is moving forward and it is coming closer to this particular these two nucleus. Okay, now you see over here this electron has three paths. Either it will go in this particular direction by piercing this particular gap which is present in between these two nuclei, okay, or else it will go in this particular direction. Now you will ask, how exactly it will go in this particular direction? Well, the reason is quite simple, because nucleus has what? Protons, some positive charge in it, right? So it will try to attract the electron. So the electron will flow, or electron will move in this particular direction. Okay, so this is the what? This is the changed path. Okay, changed path. CH, let's say changed path 1. Okay, my electron got deflected because this nucleus is positively charged, so it will, it got deflected, right? But you see, my current is moving in this particular direction. So what I want is that, what my desire is that my electron should flow in this way, right? It should never ever flow in this particular direction, nor in this particular direction as well, right? And the third part, if you see, there is a chance that electron will also be able to move in this particular direction, or my, the actual path of the electron gets deflected. Let's say this is changed path 2. Why? Again, the same reason, because this is the nucleus of the second atom and it will try to attract this particular electron. So due to which the direction of electron will change. But this is the desired path. This is the desired part. I want that my electron should move in this particular direction by piercing these two, by piercing the gap in between both of the nuclei, right? Okay, this is what we saw, or this is what I will see, right? So let's say I'll just take a random example. Let's say if I'm providing 10 electrons over here. Okay, so let's say these are the certain set of electrons that are present over here. Again, let me just copy those two nuclei, Control C and Control V. Okay, so these are the two nuclei. Let me copy them over here as well, so that it will be pretty easier to explain the further things as well. Okay, so you see over here, let's say if there are 10 electrons, let's say if there are 10 electrons which started the journey from this particular point. Okay, out of this particular 10 electrons, only let's say 6 electrons were able to come out of this particular conductor. Let's say over here only 6 electron arrives. Okay, now you'll ask me, what about those 4 electrons? So those 4 electrons got deflected because of the nucleus of the atom. Let's say one electron come over here, it got deflected because of this nuclei, another got deflected because of this particular nuclei. Same happened with the other 2 electrons over there, they got deflected somewhere over there. Okay, now you'll ask me, does that mean these electrons will stay in the conductor? No, just listen to this particular point very carefully. Let's assume that the 6 electron out of 10 electron came from here within a second. Okay, within 1 second, let's say 1 second. So in 1 second, what I saw that only 6 electrons were able to come out. Okay, so let me just write this particular point. It is very important. So 6 electron are coming out of the conductor in 1 second. Okay, in 1 second. Great. Okay, now this is what we saw. This is our observation. We are just observing the things, okay, with the help of microscope. Okay, yet we have not came to certain conclusion. Now what I did, let's say I increase the overall area. Okay, I increase the area. Let's suppose my A2 is greater than A1. Let's suppose it become 1.5 or 2 times of my A1. Okay, my area 2 is, let's say, 1.5 or 2 times of A1. Whatever is convenient to you, you can take that particular value. That is absolutely fine. Okay, great. Now what I saw was that the moment I increase the area, the intermolecular spaces between the nucleus of an atom, that also increase. Now what does that mean? This sentence might look confusing to you all guys, but it's very simple. So you see, the space between these two nucleus, let's say it is x. Okay, if the space between these two nucleus is x, so you see the space or the intermolecular space between these two nucleus has increased. Let's say it is 2 of x. Okay, 2 of x. I hope this particular point is crystal clear. So as the intermolecular spaces between the nucleus of atom has increased, so what does that mean? That means, again let me take the same thing over here. So yeah, as the intermolecular spaces between these two nucleus has increased, yes, of course there is one more nucleus, that is for sure, but intermolecular spaces has increased. That is the most important thing. So you see, if there is this particular electron which is coming over here, right? now there is high amount of chance for these electrons to pierce from this particular gap and to come over here, right? So let's say if the probability of electron in this particular case, in case of A1, if the probability of electron to move from this point to this point, let's say if it is 60%, okay, so this probability or this particular chances increases to up to 90%. Okay, very few electrons will get deflected. Why? Because the intermolecular spaces between these two nucleus, it is quite high as compared to the previous case. I hope you are able to understand this. Okay, and on top of that, you see the electrons which are present over here, that means the incoming electrons. Okay, incoming electrons, they are quite high, or the number of the incoming electrons, they are quite high. Let's say there are 15 electrons. Okay, in above case, what we saw, there were just 10 electrons which were coming at this particular point, but now there are, let's say, 15 electrons which is getting accommodated at this particular point. Okay, so first thing is that number of incoming electrons has increased. Secondly, the intermolecular space, okay, the intermolecular spaces between the nucleus, that has also increased, right? And since that has increased, so the chances of electron to pierce this particular gap, it has also increased. I hope you are able to understand this particular point. So let's move on to the next point, that is, let me just write over here few of the things that we discuss. The very first point is that for A2, okay, so this was for A1. Okay, so this was for A1. Now I'm talking about A2. So whatever point I'll write, this will be for A2. One second. Let me just move it somewhere over here. Yeah. So for A2, what we can say is that, let me just write over here. First, incoming electrons will be more, or incoming electrons are more, okay, because the area is increased, so it can accommodate more number of electrons or more number of incoming electrons. Okay, how these electrons came over here? Because of the voltage that we applied. Again, I know that you all guys don't know what exactly is the voltage and all. That's fine. Just assume that, I supplied these electrons. Okay, that's it. I just provided few electrons over here. That's it. Okay, and how many electrons? Let's say 15 for instance. Okay, 15 electrons. Okay, so as you can see, the number of electrons has increased, right? Earlier it was 10 electrons, now it is 15 electrons. So the incoming electron has increased. And secondly, you see the intermolecular spaces between the two nucleus of an atom increases, right? Intermolecular space between two nuclei increases. I'll write it in this way. Okay, and due to which what? If this particular electron, let's say, sorry, wait, I'll just draw. Seems that I won't be able to select this set of electrons, so I'll just draw. That means if this electrons come over here, so there is high amount of chance that this will pierce this particular gap and it will come somewhere over here, right? So that means what? If more number of electrons are piercing these particular gaps which are present in between these two nucleus, then what is going to happen? So more number of electrons will come at the output side, right? So this becomes our third point. Outcoming electrons are also more. Outcoming electrons are more. Okay, so let's say what I'll do is that I'll just move this entire thing somewhere over here so that I may get enough space to show a few of the things. Okay, just move this arrow somewhere over here. Alright, so let's say 13 out of 15 electrons came over here. Okay, so out of 15, 13 electrons came per second. So you see the flow of electron has increased as we have increased the overall area of a conductor, right? Why? Because of three reasons. Firstly, incoming electrons are more. Secondly, the intermolecular spaces between the nucleus of the atom has increased. Thirdly, obviously, since the intermolecular spaces has increased between the two atoms, so therefore the outcoming electrons or the electrons which were present over here, they can easily pierce this particular gap, okay, and they can easily come out of this particular conductor. So due to this reason, okay, 13 electrons per second are coming. Okay, this is just a rough estimation. As I had clearly mentioned, the electrons are quite high in number. 1 coulomb of charge is like 6.25 into 10 raised to 18. Okay, but this is just for your understanding purpose. I have demonstrated these numbers, okay, so that you should not get confused. Again, the same question, then what about those 2 electrons? So those 2 electrons got deflected due to the nucleus of the atom, but yes, they will come back maybe at the second. Okay, I hope you are able to understand this. But you see, the rate of flow of electron is surely more in the second case as compared to the case 1. Okay, and this is what I wanted to show you. And in fact, if you try to calculate the percentage, so the percentage of electrons are 85. So 85% of electrons, they are coming out. 85 to 90% of electrons, they are coming out of the conductor, whereas you take over here, let's say only 60% of electrons, they are coming out of the conductor. So you see, the percentage of electrons that are leaving the conductor is quite less as compared to case 2, right? I hope you are able to understand this. Okay, I really hope that you are able to understand this. So what we saw is that number of electrons, I'll just write over here, number of electrons moving in area 2 were more as compared to area 1, right? This is what we saw. Okay, and if you could remember, number of electrons is somewhat proportional to the number of positive charges. As I clearly mentioned, there isn't any such positive charge, but the atom gains certain positivity. If you could remember in the session of the direction of current, I had clearly mentioned that particular point, right? So number of electron is directly proportional to the number of positive charge, and as I clearly mentioned that there isn't any such concept of positive charge. Just the thing is that the atom gains certain positivity for certain time period, right? So it is relatable to current. And in fact, if you could remember, if you are unable to recollect this, you can also remember that if the electron moves from point A to point B, so the current moves in the opposite direction, right? So current is nothing but, let's say if I have 1 ampere of current, so that means what? 6.25 into 10 raised to 18 electrons are moving in certain direction. Obviously the direction of current is different, okay, but it is relatable with current, right? So let me just write that over here. So all of these things, they are relatable with current. I hope you are able to recollect all of those particular points which we discussed in the previous session. So these two things, they are relatable with current, okay. And more number of electrons means more current, right? So in area 2, there were more number of electrons that were coming out per second, okay. This is very, very important, per second, okay. So let me just write over here, more number of electrons means more amount of current, right? More number of electrons means more amount of current, right? More amount of current, right? So therefore, as area increases, what we concluded, as my area is increasing, number of electrons that are coming out, they are also increasing. That means what? The current increases when we increase the area, right? I hope you are able to relate all of those things which we studied just now. So let me write this particular point as well. That is, Therefore, as area increases, what we saw, current also increases. Current, which is denoted by I, that also increases, right? And if the current increases, so what does that mean? That means the resistance decreases, right? So if I say that my current I is increasing, right? That means the overall resistance decreases, right? Overall resistance decreases, right? If you could remember this particular analogy which we saw, and that's the reason that why I actually explain you this particular analogy, right? Because if you see, if I'm not applying any resistance, the flow of current is quite high, or I mean the flow of water is quite high, right? Whereas if I apply certain resistance to the flow of water, right, so what is happening? It is taking a lot of time, right? I hope you are able to recollect all of those things which we studied, and you are also able to relate those particular things over here, right? So what does that mean? That means, let me write over here, thus area is inversely proportional. This particular parameter is inversely proportional with the resistance. Okay, that is R is inversely proportional to the A, or the area. Okay, so as area of conductor increases, its overall resistance decreases. This is what it means. Okay, in simple word, that is, as area of the material, or the conducting material for sure, of the conductor increases, as the area of the conductor increases, then what is going to happen? Its overall resistance decreases. Its overall resistance decreases. Sorry. Okay. And I hope now you are able to understand this particular concept. As area is increasing, resistance is decreasing, and vice versa. Vice versa as well. Okay. So I really hope that you understood that how exactly this particular parameter area, this particular parameter area, it influences the overall resistance of any material, right? If I increase the area of certain conducting material, it is surely going to decrease its resistance. Okay, I hope you are able to understand this. And what is the reason for that? Because it can accommodate more number of electrons. Secondly, the intermolecular spaces between the both of the nucleus, it is going to increase. Thirdly, due to this, what is going to happen? The electron will easily pierce this particular gap, and they will come out of this particular material very easily. Okay, so you see over here, in earlier case, if 6 electrons were coming out per second, so now in this case almost 13 electrons are coming out per second. So you see, 85% of electrons are coming out. In this case, only 60% of electrons were coming out. So that's the overall idea when it comes to area. And thus that means what? That means since my electrons that are coming out, they are increasing, that means the number of electrons are quite high. Okay, and since they are flowing from point A to point B, right? So that means what? There is some amount of current. So as the number of electrons, as the rate of flow of electrons increases, that means what? The rate of flow of positive charge also increases. That means what? That means the overall current increases, right? I hope this particular part is crystal clear. The more number of electron means more amount of current, right? So as the current increases, that means the overall resistance decreases. Okay, so this is what we conclude. As area increases, the resistance decreases. So there is inverse relationship between both of these particular things, and this is what we saw. Okay, this is what we concluded. Okay, so let me just highlight this. It's very important. And with this, we will end this particular session. Okay, so what I'll do, I'll just end this session, and in the next session we'll see the next parameter, that is length. How exactly this particular parameter affects the overall resistance. Okay, so thank you for listening patiently. I'm ending this video over here. If you feel any doubts, if you're facing any doubts or any difficulties anywhere, feel free to ask me at any time. Thank you.